Legacy Historians Pi Migration. Aztec Technologies has 17 years of expertise in pharma solutions that matter. Our services include automation, project management, process data analytics, panel design and fabrication, and validation and compliance. Currently, we are working with over 50 clients across the globe. Aztec possesses strong expertise in OSI Soft Pi system. Our OSI Soft certified engineers possess sound knowledge of Pi system components. We have a proven track record of delivering projects involving implementation, migration, and integrating third-party applications with OSI Soft Pi system. We are also equipped to provide 24/7 support, which involves proactive monitoring of the system with automated solutions in place, like Pi AF notifications and Windows PowerShell scripts. Historian migration to Pi. Aztec can perform legacy historian migration to Pi, and the historians that include, but are not restricted to, DataPark, Wonderware Historian, Siemens Cymatic Process Historian, Rapid Historian, Honeywell Uniformance Process Historian Database, Rockwell's Factory Talk Historian, and AspenTech IP21. The OSI Soft Pi system infrastructure consists of 450 types of interfaces. We can use them to connect to various types of data sources and pull the data into Pi Data Archive. From Pi Data Archive, data can be pulled to third-party applications using either Pi System Access or Pi Integrator. We can use OSI Soft's Pi Visualization Suite to pull or transfer the data to Pi native client tools such as Pi Vision, Pi Process Book, and Pi Data Link. The migration phase involves assessment, where we first analyze whether we really need to migrate the legacy historian to Pi system and the advantages or disadvantages associated with it. Planning. Then we devise a plan to perform the migration. Preparation. The data, environment, and users are prepared for the migration. Migration. The data, users, and dashboards are then migrated into Pi Historian. Go live. Once the migration is complete, the system goes live. At this stage, we validate the system and help users in learning the application as well. As part of assessment and planning, at Aztec, we perform a risk assessment to mitigate the risks and chalk out a plan to mitigate all chances of data loss. During this assessment, we identify the third-party applications which interact with Legacy Historian and develop a plan to integrate the third-party applications with newly configured Pi Historian. During the preparation phase, we prep the system for actual migration, connect all the PLCs to OPC server, prepare the list of servers where the Pi components need to be installed, and establish the connection between OPC servers and Pi system using DCOM configuration. During the migration phase, we configure the Pi systems, like Pi Data Archive, Pi AF, Pi Interfaces, and Pi Vision. We create backdated archive files and Pi tags to migrate the data into the new system. We then integrate the third-party applications with Pi system to ensure the business process remains seamless. We rebuild all the dashboards and trends in Pi using Pi native clients like Pi Process Book or Pi Vision. We also replicate all legacy historian users into Pi system. Backfilling process. There are several methods, like scripts, interfaces, connectors, for performing historical data migration from various legacy historians to Pi Historian, and a suitable method can be selected based on the source of the data. If the source of the data is a simple text file, then we go with either PyConfig utility or PowerShell script. If we have the required license, then we can utilize PyUFL interface to backfill data from text file to new PySystem. If the source is OPC HDA server, then we go with PyOPC HDA interface. If the source is an SQL server, then we can utilize PyRDBMS interface to backfill data. If the source is another PySystem or Rockwell's FactoryTalk historian, then we can utilize Py-to-Py interface to backfill data from older machine to the new system. If the source follows OPC UA protocol, then we can simply use PyOPC UA connector to backfill data into new PyHistorian. At Aztec, we conduct extensive post-migration activities to know whether the migration is successful or not. As part of this activity, we perform data validation to ensure the data are accurate. We compare the historical data between Legacy Historian and PySystem using dashboards or Excel add-ins. We also compare real-time data between the source server and PyServer to ensure there is no discrepancy. Here is a sample migration. For a client, we performed migration from Rapid to PyHistorian to overcome the drawbacks in the existing historian. As per the requirements, we configured the PySystem for both 45 and 51 trains. We then migrated all the historical data from Rapid to Py, created all the dashboard and trends in PyClient tools, and trained all users on PyClient tools. Finally, after the migration was successful, we decommissioned the Rapid Historian. The system's architecture prior to the migration had a standalone Rapid Data Historian with single PyOPC DA interface, which pulls and transfers data from Delta V AppStation to Rapid Historian. During the migration process, we configured PyOPC HDA interface, which connected to Rapid Data Historian and pulled the data from Rapid to PyData Archive. We followed a 5-phased approach for the migration, which included assessment, planning, preparation, migration, and go live. During the assessment, we identified all the data, dashboards, and trends that required to be either backfilled or rebuilt in Py. We also learned that Py migration helped the business in maintaining consistency with other historians in their suite. As per the plan, we utilized PyOPC HDA interface to backfill historical data from Rapid Historian. We prepared the system for migration by configuring the PySystem, that is, PyData Archive, PyAF, PyInterfaces, and created backdated archive files on PyDA to store the historical data. During the migration, we configured all the tags available in Rapid Historian on Py. By running PyOPC HDA interface in history recovery mode, we were able to backfill the data from Rapid to PySystem. We then configured PyOPC DA interface to collect real-time data from Delta V OPC servers. We recreated all the users in Py and rebuilt all the dashboards in PyClient tools using PyProcessBook or PyVision. After the migration was successful, we made the system live. We then validated all the data, trained all users on PyClient tools, and decommissioned the Rapid Data Historian. System architecture post-migration. To overcome the challenges with Rapid Historian, like high availability of data or system, we came up with a solution by configuring PySystems in high availability mode and PyInterfaces in failover mechanism, like 2-level failover mechanism. One as server-level failover and the other as interface level failover. By following this architecture, we were able to achieve the client's requirement. For this migration, we utilized Pi native tools like Pi Processbook, Pi ICU, Pi OPC HDA or OPC DA interfaces, and Pi SMT. Using these tools, we were able to complete the migration easily. We utilized Pi Processbook for data validation. To configure the interface, we utilized Pi ICU. To backfill the data, we used Pi OPC HDA interfaces. To get real-time data, we used Pi OPC DA interface. To perform configurations like user configs and system security, we utilized Pi SMT tool. We have 4 branches in the US and 2 in India.